Welcome to our channel, Stormrider. The USS Gerald R. Ford, CVN-78, represents the cutting edge of naval engineering and stands as a symbol of American power and technological advancement on the seas. As the lead ship of the new Gerald R. Ford-class aircraft carriers, it replaces the aging Nimitz-class carriers with a design that brings improvements in almost every aspect, from its propulsion system and aircraft launch technology to crew efficiency and combat capabilities. Named after the 38th President of the United States, this nuclear-powered supercarrier is not only the most advanced warship ever built, but also one of the most expensive, with a price tag exceeding $13 billion. But beyond its cost, what truly makes the USS Gerald R. Ford special is the combination of innovation, automation, and performance that defines the future of naval warfare. At first glance, the USS Gerald R. Ford looks similar to its predecessors, a massive flat-top floating city stretching over 100 feet long and weighing around 100,000 tons. But beneath the surface, it is an entirely different beast. The ship's design emphasizes efficiency and modernization, featuring more than 23 new technologies that were never before integrated into a single carrier. One of the most talked about advancements is its new Electromagnetic Aircraft Launch System, commonly known as EMALS. Traditional carriers used steam catapults to launch aircraft, which required heavy maintenance and had limitations in controlling the power levels during launch. EMALS replaces that with an electromagnetic system, allowing smoother acceleration, reduced stress on aircraft, and faster recovery times between launches. This means the carrier can launch more planes in less time, enhancing combat readiness and operational tempo. Complementing EMALS is another innovation known as the Advanced Arresting Gear, or AAG, which replaces the traditional hydraulic arresting systems used to recover landing aircraft. The AAG allows for more precise control during landings, especially for lighter aircraft such as drones, which will play an increasing role in future naval operations. Together, EMALS and AAG make flight operations safer, more flexible, and more efficient than ever before. The Ford-class carriers are designed to handle up to 25% more sorties per day compared to Nimitz-class ships, meaning they can conduct more missions and deliver greater firepower when it counts. The USS Gerald R. Ford is powered by two A-1B nuclear reactors, each generating nearly 3 times the electrical power of the older Nimitz-class reactors. This enormous energy output not only supports the ship's propulsion, but also powers its advanced systems and leaves room for future technologies, such as directed energy weapons and advanced radar systems. With nuclear propulsion, the ship can operate for more than 20 years without refueling, allowing it to stay deployed for extended periods anywhere in the world. Its top speed exceeds 30 knots, or about 35 miles per hour, which is impressive considering its massive size and displacement. One of the most remarkable aspects of the Gerald R. Ford's design is its focus on reducing crew workload and operating costs. Automation and smarter systems have allowed the Navy to reduce the ship's crew by almost 700 sailors compared to Nimitz-class carriers. This reduction might not sound significant at first, but over a 50-year service life, it translates to billions of dollars in savings in salaries, food, and maintenance. Inside, the ship offers more comfortable living quarters, better air conditioning, modernized workspaces, and even improved cafeterias, small details that make life easier for sailors spending months at sea. In terms of air operations, the Ford can carry around 75 aircraft, including FA-18 Super Hornets, EA-18G Growlers, E-2D Advanced Hawkeyes, and helicopters. It is also designed to operate future aircraft like the F-35C Lightning II stealth fighter and unmanned aerial vehicles. The flight deck has been redesigned with a more efficient layout, including fewer obstructions, wider taxiways, and advanced weapons elevators. The new electromagnetic weapons elevators, which use linear motors instead of cables, can lift ordnance faster and more reliably. This ensures that planes can be rearmed quickly and sent back into action with minimal delay. When it comes to defensive systems, the USS Gerald R. Ford is equipped with state-of-the-art radar and sensor technologies. Its dual-band radar system combines multiple radar frequencies to provide better tracking and detection capabilities, while reducing the number of separate antennas required. This streamlined setup cuts down on maintenance and improves the ship's stealth profile. For close-in defense, the ship relies on a combination of the RIM-162 evolved Sea Sparrow missiles, rolling airframe missiles, and the Phalanx close-in weapon system, which can destroy incoming missiles or aircraft within seconds. Another area where the Ford class excels is in survivability and maintainability. The ship's hull and internal structure have been designed to better withstand battle damage, while systems are more modular and easier to repair or upgrade. This modular approach means that future technological updates, like laser weapons or new electronic warfare systems, can be integrated without major overhauls. The Navy specifically designed the Ford class to serve for over half a century, making adaptability a cornerstone of its construction philosophy. Beyond the technical side, the USS Gerald R. Ford carries immense symbolic value. It represents America's ongoing commitment to maintaining maritime dominance and the ability to project power anywhere on the globe. An aircraft carrier is often described as a floating airbase, and with the Ford's enhanced capabilities, it serves as a mobile command center capable of launching airstrikes, supporting humanitarian missions and providing deterrence in contested regions. The presence of a carrier like the Gerald R. Ford in international waters is often enough to shift the balance of power in a crisis situation. Of course, this groundbreaking vessel has not been without its challenges. The ship faced numerous delays and budget overruns during its construction and testing phases. Many of the new technologies, like EMALS and AAG, encountered reliability issues early on, requiring extensive fine-tuning before reaching full operational status. Critics pointed to the high costs and technical setbacks as signs of overambition, but the U.S. Navy maintained that these innovations were necessary investments in future capability. As the ship has matured through trials and deployments, most of those issues have been resolved, paving the way for future Ford-class carriers to be built more efficiently and at lower cost. The USS Gerald R. Ford officially joined the U.S. Navy fleet in 2017 and achieved its first full deployment in 2023. During that time, it participated in various exercises and international missions, demonstrating its ability to carry out sustained operations alongside allied navies. Its performance has validated much of the original vision behind its creation: a more powerful, efficient, and flexible carrier that can dominate 21st century naval warfare. In conclusion, the USS Gerald R. Ford, CVN-78, is more than just a warship. It is a floating demonstration of technological evolution and strategic foresight. With its advanced systems, reduced manpower requirements, and enhanced mission capabilities, it represents the future of naval aviation and maritime power projection. While the path to operational readiness was not smooth, the end result is a vessel that sets a new benchmark for what an aircraft carrier can achieve. Whether launching cutting-edge aircraft, supporting global peacekeeping missions, or deterring adversaries, the Gerald R. Ford stands ready as the flagship of a new generation, one that will shape the seas for decades to come.